So this video is going to be about vector addition. We've seen a little bit of vector addition in Calc 3, but I thought I'd do it one more time here just to be sure we understand how it works. So let's just do an example here. I'm really interested in doing this geometrically. So if I have one vector here, let's call it V, and a vector here, if we call that U, then typically what you would do for the sum is you would take the V and the U, and then you can draw a parallelogram where this side is parallel to this vector. These two sides are parallel, and then these two sides are also parallel. Okay, and then going from the origin out to here, maybe I should draw that in a different color. This then would be the sum U plus V. Okay. Similarly, we could draw the vector U minus V as well. So if I wanted to draw U minus V, let me go ahead and just draw U and V first. U minus V, I would take U minus U plus V, right? So I would draw minus U first, and so that's just taking U down here, so that's minus U. Okay, and now I can draw the sum, or my parallelogram here, and so if we draw the parallelogram, and then we see that the resulting vector here is going to be V plus minus U. Right, good. Alright, so you can also see we can do other things similar to that. So how would I draw, for example, here's my U and V again, U, V. How would I draw, let's say, 2U minus 1/2 V. Okay, so I would take my graph, and I would go ahead, so 2U would be twice this, right? And so this would be my 2U there, and then if I want minus 1/2 V, I'm taking V backwards. Is that about 1/2 right there? Oops. I'm trying to be fairly accurate. Okay. And so then we can do our parallelogram. Let's see if I can draw these lines parallel to each other. Does that look pretty parallel? Pretty close, I think. Okay. Okay. And then this would be my vector then, 2U minus 1/2 E. Good. Now, I wanted to say, alternatively, suppose that I did something like this. Here's a point. I want to write the point as a linear combination of U and V. Okay, so how would I do that? Well, geometrically, there is a way to do that without guessing too much. The idea is that you can draw a little bit of a, you can draw some lines here representing +1 and -1 U, and then maybe I'll go ahead and draw this first here, and then this one's going to be parallel. You see what I'm drawing here? Oops, that's too close. Oh wow. Okay. Maybe one more of these. That should be parallel here. Okay. So you see what's happening is this would be minus U, and this would be minus 2U. And then this would be, so this would be like minus if I wanted to go here, minus u plus v, right? Or minus 2u plus v. Whoops, I'm flipping you guys around here. Let's see if I can get you back. Somehow my drawing just went. Okay, I don't know why that just did that. Now I can't get it back. Okay. Oh, did that go back? Pretty close. Okay. I'm not sure why it's not behaving. Okay. So, so do you see how we're going to get this point? Let's see if I can get my arrow there. Okay, now I'm back. Good. So now to get this point, right, I've got, let's see, minus 1, maybe minus 1/2 more, and then plus 1, and plus, oh, what is that, about 2/3? Right? And that's minus 1 and a minus 1. So it looks, minus 1/2. So it looks like this is about minus 3/2 times u plus 5/3 v. And so this is just a rough estimate, right? But you can see that given this, so for example, this point here would be my u plus v, and so you know, you could get, if I give you any point in the plane, right, we should be able to estimate coefficients for u and v such that that point is a sum of u plus v. Okay, so there's a set of exercises on the class website that's drawn a little bit better than I've drawn it. See if you can get those to work out. Those are actual numbers, so you can verify yourself arithmetically if you want. Okay, that's it for now.